and in this video we will look at a very simple multi-site next generation firewall design, right? The goal of this video is obviously not to do a lot of configuration as such. We will actually explore the configuration which has already been set up, but the goal of the video is to look at the operation side of things, right? So once you have once you have firewalls in your environment, right, how do you manage it, how do you administer them, and probably how do you troubleshoot some of the very simple issues on a day-to-day basis, right? So that's the goal of this, right? For in-depth Firepower series, you can go to my channel and you'll probably find a section called Firepower, right? 6.6, that's the last release which I explored, and you'll find in detail, videos on each of the policies and so on, right? That being said, let's just get to know our topology a bit before we actually get into the FMC, right? So what do we have here? So we have a very simple setup here. So we have, let's look at the branch. So we have a branch where we have like a FTD, right? FTDV, and you have two segments, in zone and out zone. As you see here, very typical design, right? You're going to have your in zone basically is nothing but set of interfaces which are from where the users are going to come and connect, and the out zone is towards the WAN. Similarly, on the headquarters side, this is the headquarters, and we have another FTD here. And here, if you see on the inside, we have multiple segments, right? In zone 1, 2, 3, 4. We don't have any resources right now in 2, 3, 4. We just have them in zone 1. And then you have the out zone, right, which is security zone pointing towards the WAN. And in zone 1, we have few things like our FMC itself is sitting, in the first zone. We also have like a Splunk server, right, so that we can probably in future, enable people from the branch or people from internet to kind of, directly NAT into the firewall and connect to the Splunk without having to be on, inside the data center or inside the network. Similarly, we have, a couple of hosts, right? We call it inside Linux, and then we have outside Linux. This is the internet side of things, right? So you can see this WAN has a breakout of internet, and the outside Linux is basically emulating a device or a service sitting out in the internet. And finally, one web server, because that's also very common in a normal, organization's data center, right? So this is what we have, very, very simple setup, right? The goal here is, like I said, to look at how to, configure something very simple like this, right? Mainly look at the access control policies, look at the NAT side of things, probably, and then look at how to troubleshoot some, simple issues, look at features like packet captures and so on. Okay, so that being said, let's probably jump on to our FMC to kind of, spend few minutes on seeing the, configuration constructs to kind of bring this up, at least the bare minimum of it, right? We'll not be doing like very complicated SSL decryption and all of that, but bare minimum policies and so on, right? That's what we're going to look at now. All right, so we are on my FMC now, and the first thing probably we'll look at is, let's go to this objects section, right? Because when you're starting with your design, the first thing you need to figure out is what are the various objects I would need, which will help me with my configuration later on, right? So one of the simple thing I can show is probably the a network object which we have created here for the whole lab subnet, right? So the whole lab subnet is this one, the /15 network, and we have created a network object. Because we have created this, now we can use this object later in our policies, right? Reusable objects, right? That's the cool thing about objects. Similarly, the other common object we use is interfaces, right? So if you look at the interfaces here, there are a bunch of security zones showing up, but technically, when you come to interface, there are actually two important objects here. One is the security zone, the other one is interface group, right? Interface group is basically a way to kind of group multiple interfaces, and you can have overlapping interfaces, like you can have the same interface in multiple interface groups. But that's not the case with security zone. Security zone is like a segment in your network, right? So you can't have one interface in two different security zones. It has to be one interface, one security zone, right? That's the main difference between those both, right? And this is how this is what we have created for our design. You can create you can add on to it based on your setup. All right, cool. Coming to the next section. So once you have done with your basic housekeeping, next is obviously adding your devices to FMC, right? We will not be doing that. We have already added the devices here. So you see the devices appear here. In fact, the devices which will be mainly concentrating are the first two devices, right? So, but if you want a refresher, go back to my channel and look at those videos where, in order to add a FTD to FMC, you need to do some bare minimum configuration, right? You need to put in the IP address of the FMC, you need to put in a shared secret key and so on. So a little bit of housekeeping is needed, and you will have to first add a bit of configuration on the FTD and then come to the FMC and add the same FTD to the FMC, and after that this particular device will be visible here, right? We have done that already, we will not get into it. We have come here because we want to look at the device. So let's click on the device, and these are the interfaces of the device, right? You can see a bunch of, there is an out zone interface. So these are the logical name for the interfaces, and these are the security zones to which they are mapped. You have on the inside you have multiple zones, right? Zone 1, 2, 3, 4. Out zone, there is one interface pointing towards the outside, the WAN side of things, and there is also an example here on how to create sub interfaces, right? If you want to create sub interfaces, you can do that as well, right? And you can create sub interfaces and assign them IP addresses if that is your goal. Like if you want to tag, if you have traffic coming using a particular VLAN, then you can segment it that way as well, right? So yeah, that's mainly the interfaces side of things. Once you're done with the interfaces, the next thing probably you should think of is the routing side of things, right? So because you want your firepower or the FTD device which is sitting here, which is actually inline, right? So this is the device which is going to forward the traffic to either the internet or the other branch, right? So you need some routing on it to do that, right? And we are using obviously static route. You don't have to concentrate probably on the first one because that's just a one specific route for a particular network, which we'll probably look at it later. But the main static route which is important for our design is this one, right? There's nothing but a default route. When you use any IPv4, you're basically using a default route and you're saying all the traffic, right? Send it to the outside interface on to this particular gateway, which is nothing but the ISP or the WAN device which is there here in the middle, right? 198.128.1. Now once you're done with the routing side, policies, right? Now you have different types of policies. We have talked about this before. Let's look at probably the access control to begin with. So in the access control, forget about the rest of the policies. The one which is of concern for us is this one, right? The NGFW policy. So you can go and click the pencil mark, and that's where you get the policy, right? You have a bunch of policy here. Instead of going through each of them, let me probably pick maybe one of them, the last one, right? So what do we have here? So this is basically a policy which is allowing access, because we know this fundamental concept about firewalls, right? For the firewall to allow traffic to flow from one security zone to other security zone, you need some kind of access list, right? You need a policy which will allow it. That's the whole job of the access policy, and that's what we are doing here. So this is a very interesting policy. I wanted to pick this one and show it to you guys because you might have seen from the diagram here, you see this FTD, both the FTDs are managed by the same FMC. So your question might be, Joel, this is the FTD which is there on the branch, right? And it has one of its interface on the public, on the WAN side of things. But how is this FTD going to reach to this FMC which is sitting behind this FTD, right? That might be a question, and that's a valid question. What we are going to do here is to make this work is use NAT, right? We are going to basically use static NAT here. We are going to map this particular, the internal address of this FMC, which is what, 198.19.10.20. that is what you see here. If you are not able to see, this is what I mean, right? This one, we are going to map this to a public address, right? Here, right? Public address from one of these pool, right? So now when this FTD wants to talk to this FMC, all it has to do is try to talk to this public address which we use, right? And then the FTD will kind of NAT the traffic to the FMC, right? So to make that happen, you want two things. You want NAT policy and you want access control policy as well. So on the access control policy, you can see this is the name of this thing, and you can see the zones. So we are telling the traffic is going to come from out zone and it is going into the in zone, which is correct, in zone 1 to be specific. This is all for FTD1, right? Or the FTD at the headquarters. Networks are selected, you're saying any because you want anyone from the internet to be able to reach to your FMC, which is probably not very secure, but yeah, for this example it works. And you can see the destination network is the FMC private, right? So this network object is basically nothing but, you see, it is showing what is the IP address over there, which is 198.10.120, right? So that is the that's basically nothing but the private IP address of the FMC. In the policy, you don't have to use the public IP address of the FMC, because why? That's a good question, right? Because the NAT is going to happen first, and then the access control policy is going to be applied, right? As per the operations, as per the order of operations in the FTD, right? That's why we are using the private address here. That's mainly it, right? So this, and then if needed, we can also, I don't think we are, okay, we also have like an intrusion policy added here, and a file policy which has been added, you know, so that we can prevent any kind of malware or specific file types, you know, during this access, right? So that's mainly it. That's how you can, that's how simple it is to create a, you know, access control policy. So we have, like I said, let me just say, do you want to save? Yes. So you can see we have one policy. Let me just pull this to the right. Yeah, so we have on the top we have access control policy to allow people to connect to our Splunk instance, right? Which is actually, which I've shown you in the diagram. So this is basically Splunk access. So people from outside will be able to access the Splunk which is inside our data center. And same thing, and the next policy is basically to allow outbound connections, right? Because anyone who is sitting in our data center or is sitting inside the network, inside the headquarters, should be able to reach to the internet, right? So you want a policy for that as well. So we have a policy for that, going from in zone 1 to out zone, right? And we are doing an allow on it, right? The action is very important. And the last one, like we spoke about, it's basically for FMC. And you see the default action here is blocked. So apart from these three things, any other traffic types come into play, any other traffic will be blocked. Since we were talking about the file policy and intrusion policy, right? Let's actually look at that as well. So you saw where we attach those policies, correct? You can, again, we can go to the pencil mark. You see in the inspection section, there are two options. One is drop down for selecting intrusion policy, other one for file policy and the malware policy, right? But what are these both, right? Intrusion policy is basically, do you want to save? Yes, right? So intrusion policy is basically a bunch of, you know, snort rules, right? So where do we see that? So let's go to policies. See in the policy section, you have something called intrusion, right? So this is where you can create an intrusion policy. You can create an intrusion policy, and then you have to go and attach it to the access control policy where I showed you earlier, right? So here we have created something called demo intrusion policy, and if you want to see the rules which are part of it, either we can look at Snort version 2 or the latest one is version 3. If you look at version 3, see these are all the rules. Here you see the total number of rules which have been selected is 46,000, right? And system defined intrusion policy, you know, there is actually a system defined intrusion policy, which is like, I think there are 3 or 4. The one which we are using is balance security and connectivity, right? We have talked about this in earlier videos. You can look it up, but we are using this as our base policy. And on top of that, you know, once you select that as a base policy, you can do some changes on it. If you don't want to use the existing policy given to you by Cisco, you can edit them, right, based on your requirements. Like here you can see overridden is 1, right, which means that we have changed one of it, and that's basically the first one. We'll actually do this demo later, but what we have done is one of the policy, let's say we were not happy with it or we wanted to customize it, you can customize it, right? So we have changed the rule action to block here for this particular, you know, rule, IPS rule, right? So that's your IPS. The other one, what is the other one? So we talked about this. Other one is the malware and the file policy, right? So this is the place where what you can do is you can, the one which we are using is the demo file policy here, right? What you can do is basically you can define what kind of files you want to block, right? What kind of files you want to block. So here you can see the action can be, you can do just block or you can do block malware, right? So we are doing block malware because, you know, we want, we don't want to just block users downloading a PDF. We want to block if the PDF what they are trying to download is probably not an actual PDF but a malware, right? So for that you need to select this action, and you can see these are the category of files we are inspecting or we are checking, right? So that's pretty cool. So you can create file policy like that, right? And then this is just one rule. Similar, you can add one more rule. I think what we are doing in the second one is we are blocking people from downloading, I think, AVI files, right? So that's something which we are doing in the second one, right? So this way you can add more stuff, add more rules here. So once you create these two policies, which are your intrusion and malware, you can then go and attach them to the access control. There's one more thing which I probably forgot mentioning while we were looking at access control. Let's go back there because that's important. So if I go to the access control policy, if I look at my access control, there is a section at the last. What is that? Let's click on probably one of the policy here, maybe this one. So what I can do is I can go to logging, right? And it's very important, maybe not in this one, maybe we have done this, probably a different one. Let's see, maybe this one. Yeah, logging. Yeah, so here you can see we have enabled log at the end of the connection, right? So this is logging. Logging is very important. Enabling that is really good because then you can see those events, once the adversary, maybe you have been infected by a certain adversary, then you'll basically get to see all that information, the logs, right? Especially the allow and the block. Whenever the traffic is getting blocked by these policies, that will get logged, and you can go to your analysis section and you can look at those events. Right? It's very important to have that. Right? So yeah, that's that. Let me just cancel that. Okay, now probably we'll look at the other important thing, which is the natting part. So we looked at the policies, mainly the access control policy, the intrusion, and the file and the malware. For Nat policy, you need to come to devices, you need to come to the network Nat section. All right, and the policy which we are using is the default path. This is the one which we are using. So we can go and click on the pencil mark here. So here you will basically see things like Autonat, Nat rules before, Nat rules after, Autonat rules, and so on. All right. So that's mainly the different sections. What you see here is basically the way they are ordered, right? So if you have more specific Nat rules, especially you want to do some exemption from Nat and all of that, more specific granular rules, they basically go here on the top. That is Nat rules before. Autonat rules, they don't have a sequence order, right? Because they get arranged automatically based on certain rules. Like static, I think, takes more priority than dynamic and so on. So this one gets automatically ordered, whereas Nat rules after is more like think of it as a catch-all kind of a thing, right? So like here in this case, we are, I think, natting all the rest of the traffic, which is going from inside to the outside world, right? You see the any, right? So this is like a catch-all. All the rest of the traffic will hit this particular rule and gets natted out, right? That's the reason. It's just a ordering thing. And this is the order in which they are going to get processed as well, right? Now we spoke about Autonat, and we did not speak about Autonat. You actually saw something called Autonat, so you might have a question: what is this Autonat, right? So Autonat is, I would say, is one of the most common, or recommended way of setting up Nat. Because here you can, I believe you can match based on source and destination objects, but the predominant thing here is that the source address is the one which is going to be translated. Nothing else gets translated, right? So if you look at probably one of these examples, so let's pick an example like the first one, right? So what is the first example doing here? We are trying to provide access to the FMC. Right, so this is my FMC, which is here, and we want our FTD, which is sitting out, to be able to access this FMC through the firewall, through the NAT, right? And how do we do that? Is by using this Autonat rule, right? And if you look at this NAT rule, you can see the traffic. We are basically writing the NAT rule. It's a static NAT rule, right? You can have static or dynamic. Static basically is like you have like a one-to-one mapping here, right? And you have the in zone and the out zone mentioned, and in the translation side of things, right? This is where Autonat comes into play. Only the source address, which is the FMC private, right? This one gets translated to FMC public as the traffic goes out. So that is what you can accomplish using NAT rule and Autonat rule, and that's predominantly our use case in most of the cases, right? But if you have a little more complicated use case, right? So in this case, I think this is pretty straightforward, right? FMC private and FMC public. These are two addresses. FMC private address will be this one, 198.19.10.120, and FMC public will be an address from this particular pool somewhere here, right? So that now anyone who is on the outside, they just need to connect to this public address, and the firewall here will NAT it to the FMC, behind it, right? So that's the Autonat. But then, like I said, if you want more complicated, that is, think of things like, again, not a very common use case, but there might be cases where you might also have to translate the destination address, right? That's where we use something called as manual NAT. So all the rules which come here and here, right? So these are all manual NATs. We already have one here, so we can probably look at this. So when you say manual NAT, this is where it will show up, right? Manual NAT on the top. And here you see it has more options when compared to Autonat, correct? Because you don't, with manual NAT, you don't have to just translate the source address, but if you have a use case, you can also translate the destination as well, destination address, right? So yeah, that's the use case of this. Other use case of manual NAT is if you want to put in some exemption rules, that is, if you don't want NAT to happen for a particular IP address, then you can use a manual NAT as well, right? In our case, in this case, what we are doing is we are basically using manual NAT to translate all the source addresses which are inside my network to what? We are using the IP address of the interface, the outgoing interface, right, of the firewall, which is what? Which is nothing but port address translation, right? We are basically doing overload here. I think you just need to go back and jog your basics. Remember, we have multiple types of NAT, right? Static, dynamic, PAT. So here we are using the PAT version of it, right? Every single flow which is getting originated from the inside of the network is getting translated to the IP address of the interface. And very important thing, remember that just having a NAT policy is not sufficient. If the connection, like in this case, right? The case of probably this FMC, right? We saw that there is a NAT rule here, but also you need to put a corresponding, rule in the access policy as well, right? So that when the connection is getting originated from the outside and coming into the inside network, right, that access control rule will get activated and the access will be allowed, right? Cool. That's mainly about NAT. There is also another use case here very similar to the FMC, just to show that, look, this is how you can also provide access to the web server, right? So you have a web server in our diagram, correct? Here, so we have a web server. So even for the web server, very similarly, you can create a Autonat rule, right? So you can see the source address of the web server gets translated to a specific, address in the outside pool, right? Yeah, we are basically using static NAT, and that's a very common use case of using static NAT, right? Where you have a resource inside the organization and it has to be accessed from outside. And we are using static because that address has to be static, right? You can't keep on handing out this address to people every time it changes. So that's why you don't use dynamic, we use static. Cool. While we are there, maybe one more policy which is interesting is, let's go to policies. We looked at access control policy, we looked at NAT. The other interesting thing is the network discovery, right? So the network discovery part is pretty simple. Like for example, here if you look, there is a policy here. Let me click on the pencil mark here. So FMC has the capability, or the firewall basically has the capability to discover, right, stuff inside your network, right? Because not just inside your network, actually from everywhere, because discovering users and networks and applications is very much important to kind of correlate the events which are happening, right, in your network, right? So this discovery is super important. And I mean, if you can technically do discovery manually as well, you can run nmap scans and all of that, but having that information inside your firewall is very important, because that will help you to kind of then correlate the events which are happening, and actually not just correlate, but get the context around the events that are happening, right? So that's to kind of govern that, how the firewall is going to do this discovery. You can set up a policy, and this is the simplest policy. Now technically I can just remove this networks and put a default network. I can just put any over there, but if I put any, then basically everything will get discovered, right? Every single flow which is going through my network or my firewall will get discovered, and that is not really very that's not something which you see in production network, because there is a license, right? FMC has a license, and as per the license you have certain number of hosts which it can discover. So you wouldn't want to exhaust your license over discovering every single internet host, right? Because that will not serve any purpose. So that's the reason in a very typical production environment, what you do is you create a subnet which will enclose your complete network. In my case, it is 198.18.00/15. So you create a network, and you create an object and use this here, so that only users, only the hosts, users and applications within this only the host within this particular network will get discovered, and the rest will not get discovered. Alright, so that's mainly it. So that's like literally the bare minimum stuff which you'll normally see in any firewall, especially the firepower. Now the last part is, once you've done all this configuration, it's all about deployment, right? So in the deployment section, right now our firewall is not showing up here because we have already done the deployment, but technically you could the firewall will show up here, and you will basically select it and then click on deploy, right? So once you select that and click on deploy below, right, you will see everything it is going to deploy, all the changes in the network and so on. Alright, before probably jumping onto the testing and the troubleshooting and all of that, maybe let's also quickly have a look at the other firewall which I was talking about, which is the branch firewall, right? And the branch firewall, again, pretty straightforward. So you see the branch firewall, which is the second one here, and you see the address which is discovered 198.18.133.42, right? That's the management IP of the branch firewall. And basically to discover this, our FMC should have connectivity to this one. That's why that's the main basic minimum. The other thing is when you're like I mentioned earlier, you need that bootstrap configuration on the firewall, right? So when you do that, you need to be very careful here, because like I said, this firepower which you see here, this one is actually behind this NAT, right? But your objective is to have connection this way, right? So on this FTD, when you add the FMC, right, when you configure the FMC, you should not use this address, you should use the NAT address. So here I believe the NAT address will be something like 198.18.133. maybe 120. I'm not sure if this is the right one, but yeah, I'm just taking an example. If this is the NAT IP of the FMC, you need to use that over here while configuring it, right? That's the only change you need to remember while adding FTD, which is while adding a FMC, which is while setting up in such a scenario where you have an FMC behind the NAT. Then the rest, everything is pretty straightforward, right? So you have this firewall, the interfaces part, you can look at it like we showed earlier. Similarly, there are policies governing this firewall as well. So in the access control policy, we have some very bare minimum branch access policy, and then there is also I believe a Nat policy as well for the branch firewall, right? I'll not get too much into it because that's again very much similar to what we looked at, but accompanying its own use cases. Alright, so now quickly let's test our policies. Basically, let's test our firewall, right, if it is working as expected. So what we'll do is we'll probably do most of our tests using using this Linux server which is here on the inside and Linux server on the outside, right? So let me connect to that, give me a minute. Right, so there you go. So this is my inside Linux server on the left side, and then you have the outside Linux server as well, right? Let's do some very basic things. We know that our from the inside of the firewall, right, we should be able to reach to the outside, right? So let's see if we can access probably, see if I can clear this. Let's see if we can access probably Cisco.com, right? Cisco.com is on the internet, correct? So the traffic, basically what we have done, we have set up access control policy for anything to access, so that you can provide access to the outside world, as well as we have added NAT as well, right? We have done dynamic, or basically we have done the PAT, right, port address translation. So when you do wget cisco.com, you can see it is trying to resolve, and there you go, finally it is able to resolve, and it is able to reach as well. It loaded the index.html file, right? So that works. What else? We can try pinging this outside server which we have, right? So we are on the inside Linux, we want to ping the outside Linux. Let's see if that works through. Technically it should be allowed, right? So let's do ping outside, right? We have the host name, so you see it is able to ping 198.168.133.200. that's the outside Linux server which is working. We did this whole thing about we set up the NAT rules needed for the access to FMC, right? Let's see if that works. For that, let's get on to our Linux server which is on the outside. Let me clear the screen and let's just go inside, right? So yeah, on the outside Linux server, what we'll do is we'll try to ping what? We'll try to ping we'll try to ping the public IP of the FMC, right? The public NATed IP, which is 198.18.133.120. So when you ping this, what will really happen is this ping will hit the firewall. The firewall will NAT it and then send the traffic all the way down to the FMC. And there you go, it's working, right? So our NAT rule is working as expected. All right, so that's basically very simple checks what we did with our access policy. Now, in case when you're doing this, if something is not working, right, which might be due to some kind of misconfiguration, so you would obviously need to first check your access control policy, right? Then you will also have to check your NAT policy if you're doing everything right, right? The other important thing probably you can also do is make sure that the firewall interfaces are up and at least like for example, if I'm on the inside Linux server, I should be able to ping what? I should be able to ping the inside interface of the firewall, which is 198.19.10.1. Right, there you go, that is working, right? Similarly, if I'm on the outside interface, I should be able to at least ping the outside interface of the firewall, which will be, I believe it's 198.18. Let me see, what is the IP? Okay, I think it is 133.81 if I'm not wrong. You have to go back and check. Yeah, there you go, right? So from the outside host, I'm able to ping the outside interface of the firewall, right? Maybe also you can check is the ARP, right? If the ARP is, it's able to resolve it. So let's look at it. RPA, you can see the inside interface of the firewall, right? This is the interface, and it is able to resolve it as well, right? So at a layer 2, you can do that kind of a check as well, right? So to make sure that you have connectivity and your policies are correct and so on. Apart from that, you can also probably look at the routing table of your firewall, right? Actually, let's get on to the CLI of the firewall, right? So I think I should be able to do that. Let me do that one sec. So let's get into the FTD one. I think it's, yeah, here you go, load it, and let's open it. Okay. So yeah, so I believe it's right. So you'll be dropped into the FTD CLI, right? And here you can run show route, right? And generally you should have, basically remember we have set up the static route. You need to have some kind of routing, right? Otherwise you'll not be able to, route the traffic through the firewall. So in our case, we have a static route, and you can see all that traffic, or we have that showing up here, right? It is going towards the WAN. So you can check that as well as a next step. Make sure that your routing is working all fine. The other next step, what you could do is probably something very interesting. Some of you might have already known, most of you actually might know this is a very old feature. But yeah, something what you could do is you can go to, again, device management, go to your firewall. So give me one sec. Yeah, so the firewall, this is NGFW. So I can probably click on this 3 dots and you get a bunch of options here, right? So there's something called packet tracer, which is pretty cool. Right, you might have seen something very similar in SD-WAN as well. On the Viptela, you have an option to kind of simulate flows, correct? You don't really need to have an actual host with that IP address, right? But you can simulate flows through the firewall and see what the firewall is actually trying to do, right? So here, let's actually give this a try. So we have selected our NGFW. So let's select our, I think there are a couple of things which have opened up. Let me just close this. I think, okay, so there you go. We have a new trace. In the select device, let's select our device. What protocol we want to test? We want to test, say, ICMP. IPv4 is correct. Let's probably select the code. We want to select the code. So here let's select echo request, right? The ICMP, I believe the code, the type is 8, but I think the code is 0 if I'm not wrong for echo request. So you select that accordingly. The interface is important. Let's select the which interface. We will have to select the inside interface, right? So where is that? Let's select the inside zone 1. Let's select that interface. VLAN is not needed. Destination. So source and destination is important. So let's select 198.19.10.100, right? This is actually, I think, the IP address of my inside Linux server, but it doesn't have to be 100. In fact, let's change it to some random IP, .31, right? And the destination IP can be 198, let's say we want to ping that outside Linux server, right? So 198 dot, I think it is 18.133.200, right? So we have all the information. Now what I can do is I can simply hit the trace button. So what it is going to do is it will simulate the flow, right? It will simulate the flow through the firewall and it is going to give you the results here. And here you can see exactly what the firewall is doing, right? It is going to show you in that order, right? So this is the inside interface. The packet has come on the inside interface. Then you can see there is a bit of route lookup happening. The access list is getting added. Then the connection settings, the NATing is happening. Inspection, the flow creation, the snort firewall, which is nothing but your IPS and all of that. So you can see all these things are getting applied, and finally, the firewall is deciding, what, we are going to allow this, traffic to flow through. So once it decides that, the traffic is basically sent on the outside interface and the traffic basically flows through it, right? So this is a very good way for you to make sure that the policies what you're writing are going to work, right? Before you kind of roll it out. Maybe if you have a dev environment, right, you can try this out and you can make sure that your policies are going to work, and then kind of roll it out to the production. Now the same thing you can actually do it from where? From the CLI as well. So actually let's look at that, because there's another troubleshooting. Maybe if you're not able to get the GUI to work, you can actually do some of this on the CLI. So on the CLI again, there's an option called system support trace, right? And here I can give, it is going to ask me some questions. Enable firewall engine debug. I'm going to say yes, and specify the IP protocol. I'm going to say ICMP, right? The source address, the exact thing what we did, I think it was 198.19.10.31, right? Let's do the same thing. Destination is 198. I think it was it 18? I think it was 18.133.200, right? So once you do that, and then now again you can go back to your packet tracer, or if you have an actual packet or traffic generation tool, you can generate using that. But here I'm going to generate the traffic using packet tracer. I'm going to hit the trace again, and then let's come back to our CLI and see. You can basically see the same thing, right? You can see that the firewall has allowed the traffic to pass through. You can see the final verdict is pass, right? So this is a way you can kind of troubleshoot, or you can use the CLI to troubleshoot as well. The other interesting thing is probably looking at the hit count, right? Hit count is another thing which we normally use on a day-to-day basis as to kind of troubleshoot. So you can actually go to your policies, and let's go to the policy here, and here on the top there should be, okay, let's select our policy. Maybe we need to select it. Let's select the policy, and here you see you have an option called analyze hit counts, right? So here I can select the device NGFW1, right? And I can I can select, if you want you can put a filter, right? But in our case this is good. So, and you basically get the hit count of various policies, right? Like basically I have been running this policy for like probably a few hours now, so you can see quite a lot of hit count on this particular rule. I don't think I have done the Splunk access yet, so that's why there's 0 hit count. FMC access we just tried, so you can see 3 hit count and so on, right? So you can get this information from here, so that you can see which policies are getting hit how many number of times. Alright, so that was mainly on the access control. Now let's go and quickly have a look at our other policies, mainly our IPS and maybe the, first let's look at the IPS side of things, right, the intrusion prevention, right. So let's come back to this guy, which is my inside host. Let's go to the inside host, and on the inside host I'm going to do something not good, right. What is it? I'm going to first, let's clear the screen. Let's try to do an FTP to the outside Linux server, right. So I'm going to say FTP outside, right, and it's going to ask me for a password and username and password. I'm going to log in as probably guest this time, and right, that I've logged in successfully. Now what I'll do is, normally you use FTP for what? You use it for, sending and receiving files. What I'm going to do something bad. I'm going to probably run a command. I'll probably try to send a command called cd, change to something like root. Right? Normally people won't do this, but probably an adversary who has, who wants to kind of send an exploit might try this, might try sending some command through the FTP, right? So when I try to do this, you can see it is getting blocked, right? And so yeah, it's a bit hung, but actually the firewall is doing something. We'll actually get to see this. Let's actually see if I can come out of that. Yeah, see, it said service not available, but if you want to see what really happened, you can go to analysis. You can go to where? Intrusions, right? Because we're looking at IPS. So you can intrusions, events. So here you can see the very topmost thing. That's what really happened, right? So you can see the latest event on the top, and you can click on the small arrow on the left side, and that's basically going to give you more information. So you see this is, the result was that the packets got dropped. You see it has basically gone and marked our host, which is the inside host, right, where we were trying to initiate this connection. It has gone and marked it with red. This is what we were trying to access, and you see the rule here. We basically hit a IPS rule or snot rule, right. We can actually see more information. You can click on again this arrow mark, and it will give you more information. You can see the event information is visible here, right. Potentially bad traffic. Reason is because we hit this particular snot rule, right. We tried, instead of using FTP as it is intended, we tried to send a command through it, and it got logged in the firewall. You can also go deeper and look at even the packet information. Pretty cool, isn't it? So that's how you can see the rules, or basically the IPS events which are getting captured in the firewall. Now here the troubleshooting, probably only thing I can think of is, if you did the same thing like I did, and if you still don't see the event here, then maybe I would suggest you to look at the NTP settings, right, on your FTD and FMC, right. If there is kind of like, if the time synchronization is not happening, right, then there might be a possibility that the events might not show up immediately, right. So that's something which you can have a look at. The other thing is, if you look at, I think I probably did not double click on this. If you see the actions here, so when you click on the actions, it should, yeah, so you see a bunch of actions here. You can take one of the thing is, like, you can add a comment to the rule. You can edit the rule. You can even disable this rule. Let's say if this was a false positive, and if you don't want your users to be affected by this particular firewall IPS policy, then you can quickly go and disable it from here as well, right. So you can do the settings. Basically, you can take actions once that event is recorded. That being said, let's come to the next one. This was the IPS. Now let's look at the malware and the what's the malware and the file policy, right. Coming back to our internal server, inside server, in fact. So let's quit this, right. We are on the inside server, and on the inside server, what I can do is probably, so what we have is on the outside, right. So this is the outside server on which we are running a web server, right. So we are running a web server. Let's probably see where it is hosted, right. So we have a web server, and in this particular folder called files, we have a bunch of files, right. So what we'll do is, we'll go onto our inside Linux server, and we'll try to kind of like get these files from the outside server, right. That's what we're going to do, because we want to hit the file policies, right, the file and the malware policies. So I'm going to do wget t1, and we need to mention the host name, which is outside, right, / the location is files, and in the files, let's first pull a file which is a legitimate file, which is project X. Let's assume that you are working in an organization and this is a legitimate file, right? So I'm going to pull that file, which is projectx.pdf, and there you go, it went through successfully. You can see 100%. Great, right? We did not, our file policy allowed this file to be downloaded because it did not see a malware on it. Now what we'll do is we'll actually pull a file which is actually blocked. Remember I told you we have blocked ABI files. So let's do that. So outside files, but this time let's pull this file called test3.avi. And you see HTTP request sent, but read error, connection reset by the peer, right? So the file did not get downloaded because, like I said, the .avi file, we have blocked it. We'll actually have a look at it in the logs. And the final thing is probably let's try to download a malware file. So you see this zombies.pdf, that's actually a malware file, right? So let's try to download that. So same thing, instead of test, let's try to now download zombies.pdf. It appears as a .pdf file, but technically it is a malware file, right? So you can see it got disconnected as well. It did not go through. The reason why, how did Firewall figure out that this is a malware? Obviously using the SHA, right? Using the it's obviously going to try to download the file, but then it will calculate the SHA, right? And then it will look at the disposition, it will look up on the cloud, and it will figure out that this particular file is actually a malware file. So it will not download the file because we have enabled the malware policy. We can actually look at all these events. So let's go back to our analysis. Hope the events are captured. So let's go back to analysis, and this time let's go to the file section, and here we are going to malware events. Right, see on the very top we have the zombies file, right? So we can click on this one and you can see the same information, right? You can see our host has been it is highlighting that this host is infected, indicator of compromise, right? Whenever you see red color, and you can see on the right hand side this particular file was trying to be downloaded, and its SHA is basically this one, and it got, you can see it gives you all information regarding that. Right, so yeah, that's about the malware. You can actually also look at, let's probably click on this red button, right, or the red laptop here, and it will open up a new tab, and it will show us the whole trajectory of this host, right? It will tell us information about this host. You can see this is the name of the host, the MAC address, the what kind of operating system it is running. So it has discovered the host, right? And it is giving us all this information in one single place. It might be running some vulnerabilities and all of this information, which is very handy when you are doing some research on security events. Coming back, so malware events, what we checked, the last events is probably, let's also look at the file events. So in the file events, technically we should have that whole the MP3 file, right? So you see here, showing us MP3, but I believe, or is it on the top? Maybe let's probably click on this multimedia, right? I believe this is the one. Is this the one? Maybe not. All right, so the file events, in the file events I can see two of the when I go to the table view, I can see my zombies.pdf and the projectx.pdf, that event being shown. I don't see my the AVI file listed here. Maybe probably there's a delay for the event to show up, but yeah, that's where you can actually have a look at of your file events as well. We looked at IPS events, we looked at the malware events, we also looked at the file events. Yeah, so that's mainly about those three things. And very important things, if you don't see that your policy is actually working, especially the IPS policy and the malware policy, what you really need to make sure is that go back and check your access control policies, right? Go back and check in the access control policy if for each of the access rule have you attached, you can see these two icons here. So this is the intrusion policy and this is the file policy. Make sure that you have attached the correct policies here to the rules, because it's a common human error to kind of miss out on doing that. And if you don't do that, the policies will not get activated. So you need to attach it here if you have not attached it, right? So that's one of the first troubleshooting thing you need to make sure while checking your IPS and the malware policies. Okay. So yeah, that's the whole thing. I wanted to kind of cover in this video. We kind of let me just clear. All right, so I just wanted this to be a quick refresher of the whole next generation firewall, because I think in the current day and scenario we hear quite a lot of buzzwords, especially SASE and zero trust, where the next generation firewall plays a very important role. And with the firepower, actually you can do all of this in a very seamless way, right? You have just one control, one management center, and you can manage all your firewalls, and at the same time you can, because of the centralized architecture, you can create policies and kind of deploy them across multiple firewalls which are in different places, right, at different point of presence. That way you will have consistent networking and security policies for any user who is trying to connect to your network from anywhere in the world, right? So it plays a very huge role in case of SASE and zero trust. So this was mainly a video with that regard, to kind of give you a quick refresher, look at some of the policies and stuff which we have already seen, and how would you manage firewalls in a multi-site setup of this sort, and as well as we also look at the operation side of things, right? We looked at how to quickly look at events, how to make sense of the events, how to also troubleshoot them to a certain extent, right, to figure out to kind of make sure our policies are right and so on. So we looked at the operation side of the firewall. If you're managing firewalls on a day-to-day basis, this one is going to be helpful, right? So thanks a lot for watching, and